Today we're going to be learning factoring. I want to do a quick reminder of the diamond pattern. The diamond problems are where you try to find two numbers, one that's going to multiply to make that top number, and the two numbers need to add to make that bottom number. So I'll do problem A and you'll do problem B. I need to find two numbers that are going to multiply to 80, but add to 2. I would recommend maybe making a little list. Things that multiply to 80 are 80 and 1. And those are not going to add to 2. I could do 40 and 2. I could do 20 times 4. I could do 8 times 10. 5 times 16. And there may be others, but because I need this negative 80, one of the numbers should be negative, and I notice this pair, 8 and 10. If I make the 8 negative, I can get to 2, because 10 minus 8 is 2. So those are the two numbers I need in my list. I need negative 8 and 10. Negative 8 times 10 is negative 80, and negative 8 plus 10 is 2. So you're going to finish the diamond pattern for problem B. Then we're going to look at what's called greatest common factor. I'll do about half the problems and you'll do half the problems. In a greatest common factor situation, you're looking for a number that everything has in common that you can divide or take out of them. So for example, in problem 1, 16p plus 4. All these numbers can be both these numbers can be divided by 4. So what we do is we take out or we unmultiply by the 4, and then we open a parentheses. So 4 multiplied by what would get me back to 16p? Well, 4 times 4p would make 16p. And then 4 times plus 1 would make plus 4. Another way that you could show your work to help you think this through is to do 16p plus 4 and show that they're being divided by 4. And then that kind of helps you get this exact same answer. The 4 that we took out, and then what's left after the dividing. So I'll do another example down below. I need to find a number that 6 plus 45b can both be divided by. I believe they can both be divided by 3. So if we divide by 3, 6 out of 3 is 2 plus, and then 45b divided by 3 is 15b. Don't forget to put that common factor outside the multiplication parentheses so that if you were to remultiply these, you would get back to that original. So my final answer is 3 multiplied by 2 plus 15b, and that is the same. It's called the factored form of the 6 plus 45b. Let's look at number 4. This time, both of the terms have a common factor of n, and they can be divided by 3. So in this case, I'm going to take out or divide by both 3 and an n. So I'll have 3n as my common factor that I unmultiplied. And then 6 divided by 3 is 2. If we take an n out of n to the third, we're left with n squared. We drop that exponent down 1. And then minus 3 divided by 3 is 1. N divided by n is also 1, or cancel this out. I'll do one more example of greatest common factor, and then you can fill in the other 4 by yourself. I'll do problem 7. 14 and 21 can all be divided by 7 as a common factor. And all of these have an a in them, so I'll also take out an a. So I'll have 7a as my common factor. So 14a divided by 7, it would be 2. The a and a cancel out. 21 divided by 7 is plus 3. And then a squared divided by an a, so I'm taking one of those a's out. I drop the exponent from squared to just a single a. And then 21 divided by 7 is 3. A to the third divided by a. I'm taking one of those a's out, so I drop the exponent down to a squared. This answer is called factoring, and it's using greatest common factor. These two things are exactly the same, it's just a different format of how you write it. You're undistributing, taking out that multiple number. There is a second type of factoring. This type of factoring we call it generic rectangle and diamond problem. The reason we use it is if I look at this original problem up here, and the directions are going to tell me to factor, there is not a greatest common factor. 2, 7, and 6 cannot be divided by anything. So we're going to use a rectangle and diamond. So you're always going to make a rectangle with 4 quadrants and the diamond problem. I don't like to draw the box around the diamond. You can do that if you want to. Rule of thumb is always put the part that is squared in one diagonal corner and the number that's alone in the other diagonal corner. So I'll write those in, 2x squared and 6. Then from our previous lesson we learned that if we multiply this diagonal together, this multiplies to 12x squared, then the other opposite diagonal should multiply to the exact same thing. So those missing 2 numbers have to multiply to 12x squared. We also know that those missing 2 numbers, when I add them together, are going to add and combine the like terms to make this 7x. So over in this diamond problem, we know that we want to multiply to the 12x squared and add to the 7x. 12x squared and 7x. So now think in your head, what are some things that multiply to 12? 6 and 2, 3 and 4, 12 and 1. Well, the ones that are going to add to 7 are the 3 and 4. But in order to get to an x, we'll have to put an x with each of those. So our missing numbers are 3x and 4x. Those will multiply to 12x squared. And when I combine them together, I'll make that 7x. So in our rectangle, we're going to put the numbers 3x and 4x that we had picked. Our last 2 steps are to find what those outside dimensions would be so that this rectangle can multiply together. So what needs to go on the outside of this multiplication chart? To get a 2x squared, I'd have to have a 2x times an x. And I see that common factor going across here. Both of these can be divided by 2. So we'll put the 2x on this side times an x would make the 2x squared. 2x multiplied by another 2 along the bottom would make this 4x. To get the numbers on the top, x and 2 would need to be multiplied by 3 to make 3x and 6. Because x times 3 is 3x, and 2 times 3 is 6. Now we use these outside dimensions to write our area as a product. X plus 2 in parentheses multiplied by 2x plus 3. That's factoring. Our problem is factored. I know it's a lot of steps, so let's try another example. So once again, when I look at this problem, 6, 17, and 12, they don't have anything in common that I can divide them by and take out as a greatest common factor. So I know I'm going to need to use the rectangle and diamond. So I draw a rectangle with the 4 quadrants and the diamond problem. the squared, 6x squared, and the 12, that's alone, go into the diagonal. And when I multiply them, they'll go in my diamond problem. So 6x squared and 12. And if we multiply 6x squared times 12, they multiply to 72x squared. 72x squared. The other diagonal also has to multiply to that same 72x squared, but it also has to add the like terms that will create the 17x. So that goes in the bottom of our diamond problem. So into that missing diagonal, we need to pick the two numbers that are going to multiply to 72, but add to 17. So 72 is 6 times 12, 72 times 1, 8 times 9, 3 times 24, and there's a few others, but I can find the one in this list. 8 and 9 will add to 17. So I'm going to put 8x plus 9x adds to 17x, and 8x times 9x makes 72x squared. So I take those two numbers I picked and put them into my rectangle, 8x and 9x. And now my last step is to find those outside dimensions and write it in a set of parentheses. So let's see. Going across the bottom, these have a common factor of... I could take out a 3 or divide by 3 and an x from each of those. And then 3x times 2x would make this 6x squared. And 3x times 3 would make 9x. And then across the top, the 2x can be multiplied by 4 to get 8. And 3 times 4 is also 12. So we write our outside length times width. So 2x plus 3 and 3x plus 4. And that is our factored form of this problem, writing it as a product of the length times width. You're going to finish the greatest common factors from page 1 and then try to do these last two factoring problems on your own, setting up the rectangle and diamond. If you need help, come on to Zoom or look back at the video again.